Okay, so we looked at some problems that were the beginning level of problems using heat capacity and specific heat. Now we want to introduce the concept that is a little bit fancier, and that is that when we have heat transferring between objects, the idea we have to remember is that heat lost is equal to minus the heat gained. Now think about this. If we all went sledding in the winter and we're going down the hill and you hit a bump and you fall off the sled and you start tumbling down the hill and your hands all of a sudden are going through the snow and your gloves come off and now your hands are being dragged through this icy crystalline snow, you get to the bottom and you're laughing because you had such a good time tumbling down the hill, but your hands are cold. So you come over to the picnic table where I'm sitting with the hot chocolate because I don't go on sleds. And I hand you the hot chocolate. What do you do with it? You cup it, right? You take it and put it in your hands because you know, without taking chemistry, that hot chocolate, which is warm, will warm your hands because the heat is going out of the hot chocolate into your hands. Okay, so that's the concept we're talking about here, is that as heat's being transferred, heat lost is equal to heat gained. Just reminded me of something. When we were kids, my dad used to say that he was always responsible for me being such a famous scientist because he would teach us about heat transfer. My dad drank coffee. My mom didn't. So she didn't want to perk coffee. There were no Keurigs at this time, right? You had a percolator or you cooked it on the stove. And she told my dad he had to drink instant coffee. So he would get boiling water and then put the teaspoon of the instant coffee in there, stir it with his spoon, and he usually had a metal spoon. And there was 3 kids. We'd be hanging around, and he would pull that spoon out of the coffee and then reach out and touch us with it. And, you know, it was hot. It didn't burn us. This was not child abuse. This was entertainment in our family. And he'd say to us, I'm teaching you about heat transfer because the coffee was hot. The spoon transferred the heat to our neck. So this got to be a family joke. So we would try, as we became teenage girls, we were supposed to wait on my dad. We'd stir that coffee and take it over to him and try and catch him on the back of the neck and teach him about heat transfer. So I have a younger sister. I have 2 sisters. One also teaches chemistry, the older sister. The younger sister is an accountant. She doesn't do science. So the younger sister is making the coffee one day, and I look up. She's sitting there, she's stirring, and I can see the joy and anticipation in her face as she is stirring that coffee, and she's getting ready. My dad's got his face in the newspaper. She's going over there. She's going to teach him about heat transfer. And it was all I could do not to bust out laughing. She's stirring. She comes sneaking over there, takes that spoon out, and goes to touch it to my dad, and he doesn't move. He doesn't flinch. And she's like, what? And I'm laughing my head off. She used a plastic spoon. Okay? She didn't understand that metals transfer heat and plastics are an insulator, right? I was laughing so hard, my dad didn't move. We thought that was hilarious. That's why she's an accountant, all right? So she does help me with my income tax, so that's not all bad. All right. So the thing I learned very young, heat lost is equal to minus heat gained. So when we look at this concept, we can solve more advanced problems. And let's look at one of those right here. A piece of aluminum metal was used as a heat sink. It was at 71.3 degrees. It was dropped into an insulated cup containing 100 grams of water at 25 degrees. Does it matter that it's an insulated cup? Yeah, it does. What is that telling us? That all the heat is going to stay in that cup in the water. Okay, it's not going through the cup to our hands to warm them up like the hot chocolate. And it's at 25 degrees. The water temperature rose to 27.4 degrees. What's the heat capacity of the aluminum? Well, you think about this and you say, okay, I know the idea that the heat lost by the aluminum is equal to the heat gained by the water. So we start by calculating the heat gained by the water. We know that we have 100 grams of water and it's 25 degrees C. So I know mass and I know the temperature. I know the final temperature is 27.4, so I can calculate the temperature change. What piece of information do I need to go look up? Specific heat of water. So we know that the heat of the water is equal to the specific heat times the mass times delta T. So I go look up the specific heat. So the heat is equal to 4.18 joules per gram degree C. I looked this up in the chart. Times my 100 grams of water times my temperature change, 27.4 minus 25.0 degrees Celsius. That's 2.4 degrees C. So the heat gained by the water, now my calculator says 1,003.2 joules, but I can only keep 2 sig figs. So I report 1,000 with 2 sig figs. That bar tells me the first zero is significant and the rest of them are not. So now I know how much heat the water gained, so I know that that is the heat that the aluminum lost, right? We know that the heat of the aluminum is negative heat of the water, and we put that negative sign in there because one is gaining energy and one is losing energy. One has a negative temperature change, one has a positive temperature change. So we also know that the heat of the aluminum is equal to the heat capacity, because we don't know the mass of aluminum, times the temperature change. So the heat of the aluminum is negative 1,000 joules, 2 sig figs. That's equal to the heat capacity times the temperature change. What is the final temperature of the aluminum? That's the temperature of the water, 27.4. They equal out because the aluminum and the water are combined and they reach thermal equilibrium, right? So the final temperature is 27.4 minus the initial temperature, which is 71.3 degrees Celsius. So my negative 1,000 joules is equal to my unknown heat capacity times negative 43.9 degrees Celsius. Now you see here that I put that negative sign in front of the energy and I have a negative temperature change because the aluminum is cooling off. And that's where that whole negative number business comes in, because if I didn't put the negative sign on the left, I wouldn't have two negative numbers. I'd have a negative number being set equal to a positive number, and that wouldn't work, right? So now I rearrange negative 1,000 joules divided by negative 43.9 degrees C gives me a positive number, 23 joules per degree C. So this is a little bit fancier problem because we're combining specific heat, heat capacity, and heat lost equals minus heat gained. Okay, there's one for you. Go ahead and do this on your boards with your group.